Hello, Carly Solali here. In this video, we're going to take a look at decision structures. This is how we code logic. How do we get our programs, our scripts, our applications to make basic decisions based on the values of data that we feed to them or data that we gather from the environment. So we'll look at things like if and else, and we'll look at things like a switch statement, and we'll look at things like nesting and how to code different types of logic in these decision structures. After learning about data types and how to declare and assign values to and retrieve values from and manipulate variables, the next most useful thing that we can learn in PowerShell or in any programming language is decision structures. That's how we actually code logic. That's how we get our scripts, our applications, our programs to make decisions based on data, based on feedback, input, and output. There are several different basic types of decision structures in any programming language. And in that respect, PowerShell is no different. So the first we're going to take a look at is an if-else decision structure. Okay? And so don't worry about this function here yet. We'll go over that later at a different time. So let's just look at the code inside it. Just know that for now, putting code inside of a function, it's a way of isolating that code from other parts that are, basically in the same file, in the same page in that script. So I have all these different examples and I've put them inside of functions, and a function is designated by an opening and closing curly brace, okay? So again, I don't want to, this is about decision structures, not about functions. So I don't want to spend a lot of time talking about functions. Just understand if you see this, until we get to that part, we'll discuss it later. It's just a way to separate our code. So in this case, this example, a basic if-else structure. Let's throw it over here. And let me add a couple of lines there. All right, so we have a variable, right? My number. We're assigning it the value 444. And then we have another variable called player guess, and we initialize it with the value of 0. We'll display to the console, greetings, player 1, with both right and right host. Can you guess my number? And in this instance, with right host, we're using the no new line option. And so that'll make that appear without adding another line, okay? Otherwise, in this instance, it would drop down a line. And it's a matter of preference, I guess, but I just wanted to show you that option as an example. If you don't want right host to add a new line, you can use the no new line option. Okay, we talked about this in the last video, right? Read line. It's like the opposite of right host. Right host and write display things, output things to the console. Read line receives and takes input from the user. So we take it from the user, and then in this case, what do? We're going to store it in this variable here, okay? And we could also put some text in here if we wanted to, and we don't even have to explicitly call this, but we'll look at those options later. I'm just trying to show you several different ways of doing things, and let me turn looks like my phone is, let me turn the volume off on that, so hopefully it won't bug us. Okay, so here's the what we're interested in, what we're talking about today in this video, a decision structure, a very basic if-else statement. In any if-else statement, you're going to have the keywords if and else. And there's also ElseIf if you have a larger structure or a nested structure. But in addition to those keywords, you're going to have the condition portion, okay? And that's where something is tested, that the value in a variable or the return value or result of calling a function. You can do all kinds of things in the test portion of an if statement, which goes inside open and closing parentheses. But in this case, we're going to keep it simple. This is our first one. So all we're going to say is, does the variable player guess, all right, the player's guess, which is what we got from readline, so whatever they type in, is that equal to 444? Okay, and we could say this directly, but we could also make this a variable. And generally in your scripts, your applications, your programs, it's good not to hard code values. It's not a big deal in a very simple, program like this with only a few lines of code. But imagine you have hundreds of lines of code or thousands of lines of code. In a situation like that, if you hard code values, such as 444, or string literals, literal constants, things like that, and then you want to modify or change something in your program, you have to go potentially modify hundreds or thousands of lines of code. And it's impossible to maintain and modify a script efficiently when you hard code values into it. So what I recommend that you do, take all of your values, things that you're going to test for, things that are sort of constants in your programs and applications, and declare them as variables and objects at the top of your script or at the top of your program. And then you can change the value and the parameters of those variables that you have at the top. And that'll take care of changing it throughout all your entire program, even if it's hundreds or thousands of lines of code. Again, that might not appear so useful to you, or that might not seem like such a big deal to you in a small program like this with a few lines of code. But as we progress in these videos and our scripts get more complicated and more sophisticated, and we go from a few lines of code to hundreds of lines of code, and from hundreds of lines of code to thousands of lines, it will become much more important not to hard code values, into your scripts, into your code, into your applications. Maybe that was a tangent, but figured I'd say it before I forgot to say it. So here's a basic if else, all right? The if portion has the keyword if. You have open and closing parentheses. In the open and closing parentheses, you have the test condition. In this case, is what the player guessed, the input we got from read line up here and assigned to this variable here. Remember, assignment operator says take what's on the right and store it in what's on the left. Take what the player types in on the right, store it on what's on the left. Does it equal my number? This was hard coded, but imagine we were using this, at 20 different places in a script that had 500 or 1,000 lines of code. That would be way too hard to maintain and modify and update if we hard coded that value into all that code. So it's good to use, instead of a literal constant, to use a symbolic constant or a variable. Assign a value to a variable, then use that variable in your code. Makes your code easier to modify, easier to maintain. Okay? So the if portion, you're always going to have an open and closing curly brace with an if. Notice how ICE, and a lot of IDEs will do this, that it'll highlight the other brace. So if I do this and select this curly brace here, all right, notice that ICE highlights the closing curly brace. Might not be so important now with just a few lines of code, but when you get a lot of code, when you get lots of, a dozen different levels of nested decision structures where you have one if and else nested inside of another and another and another, which you need to do sometimes. When your decision making becomes more sophisticated and more complex, when you need more complex logic to deal with a situation. So, brace issues and knowing where a block of code is and where the opening and closing brace is, it becomes very important as our programs get bigger. So now that things are small and we're just starting out, it's good to kind of go over that. And also we'll go over indentation later. That can help on your code. I'm just trying to throw some tips out there. But all right, so open and closing curly braces. So if this condition is true, right, in the parentheses right here, then this will happen. All right, we're going to write to the console, yes, that's it. You guessed my number. Else, that's the contingency plan. If this condition here evaluates to be false, and there's operators we could plug in here, equals, not equal, greater than, less than, depends on the value. What we're doing in the tester condition, we could call a function or put a whole bunch of code inside these parentheses. And then, wrap that up inside another pair of nested parentheses, and the end result of that could then be fed into, you'll see all kinds of different ways that developers and programmers use the test condition portion of an if statement. But just understand that always goes in parentheses. And if it's true, then what is in the open and closing curly braces, that's what happens. If not, we get to our contingency. That's the else clause. Again, notice it is also an open and closing curly braces. See how ICE highlights that? It's, the default's gray, you can't really see it that well, but still it highlights it. And so then this block of code would happen. Hey, sorry, that was wrong. You did not guess my number. So let's run this code and give it a test. Console says, greetings player 1, can you guess my number? See, right? Greetings player 1, can you guess my number? And then we use the no new line option. So look, the cursor's blinking on the same line. It didn't advance to the next line with read line. And let's get it wrong. So we'll say 42. Meaning of life, right? Well, because this test evaluates the false, the player types in 42, I type 42, it gets stored in this variable. This variable equals, does it equal my number, which is 444? No, it does not. So this test condition returns false. And so rather than this block of code being executed, if the condition returned true, this block of code instead will be executed because the condition returned false. That's the else clause. Now let's run it again. I'll hit F5. Can you guess my number? 444. Bam. Yes, that's it. You guessed my number. So now, because what I typed in, what I captured with read line and stored in this variable was 444, it compares it against this variable 444. It's true, it returns true. So rather than the else block, it executes this code in the if block between the open and closing curly brace. Okay, so just to kind of give you an idea of how a basic if-else structure works. Now in this case, when it does the comparison, the test portion of the if statement, it's looking at the string value and not the numerical value of 444. Remember that read line as a method or function always returns a string, okay? And in this case, PowerShell doesn't care. It just says, well, what the player typed in, the string value, all right? So the ASCII character values are code for 444. Does that match the variable value, the string value 444? In this case, yes, it's true. The strings are equivalent. But I couldn't do math on it. I'd have to cast it to an integer or convert it to a number data type in order to do math with that, just like we did in the previous video. All right, so just sort of a heads up there. Always remember what you get from read line as a string. And if you're just comparing what the user types to something that against something that you can use as a string value, you don't have to do any kind of conversion. But if you're going to do math with it, then I'd have to cast it to an integer, all right? So I'd have to declare this to be an integer, and then I'd have to convert what the player typed into an integer. And then if I wanted to, I could add them together or subtract or do some sort of mathematical operation. We're going to build a calculator, both a console one and a GUI one, and that will become more clear. We'll go into more depth as far as typecasting and converting one data type to another. So just understand at this point, everything that we've done has been a string. So we're not looking at the numerical value. We're looking at the text or the textual representation of that numerical value. All right. So let's take a look here. In this example, this was one way, write host, and then no new line. And then we called host UI read line. Another way, we're going to run this code and do the same thing. All right, so again, my number is 444. Now, here's the string literal again. So remember, we don't want to hard code a value. So a better way to do this would be to use this variable here. And then that would be reflected all throughout our script. But this does the same thing. I'll hit F5, I'll run it. Can you guess my number? Yes, that's it. All right. So in the condition portion, it's being tested, it's true, and it executes this code. At F5, I'll type in 42. Sorry, that was wrong. You did not guess my number. Okay. But I'm just showing you another way of doing that. In this case, on one line, read host, can you guess my number? Okay. And I'm not using no new line and write host. I'm just using write. I get the same thing in terms of input and output, but it's just different ways of, coding a solution to the same problem. Okay, now what about a random number? All right, there's a built-in function or method in PowerShell called getRandom. We can use that to generate a random number. So again, this is input, output. Now, in this example, we're going to use a simple decision structure, an if-else decision structure, and we want to compare what the user types in against a number. So let's run this code here. I'm going to bring it over into test, and we'll step through it. All right. My number is a variable initialized to 0. Player guess, another variable initialized to 0. Greetings, player 1, generating a random number between 1 and 10. So the way getRandom works, you have these parameters, right? Always have a dash when you pass in a parameter to a function. And this will become more clear when we go over functions. But you have to eat an elephant one bite at a time. So we have to kind of, avoid covering that or going off on a tangent talking about functions, because right now we want to focus on decision structures. So just sort of delay, if you don't completely understand how this works or why functions are good or the usefulness thereof, just sort of delay your frustration and it will become clearer later. All right. So just understand that this is the way you call getRandom, and you have to pass in options or parameters, and they always have a dash in front of them. So this is the option, the parameter name. In this case, I want to start with 1, and then the maximum would be 11, and I'm going 1 over. Okay, so value between 1 and 10. In this case, I would always add 1 or go 1 over to my maximum value. Okay, we're going to say, can you guess my number? And read host will take input from the console, from the user. We'll assign it to player's guess, and we're just going to compare these two. Okay? Now, in this instance, again, we're not really doing math. We're just comparing string values. Okay, so, the string value of a random number to what the player types in. And then here's what we want to say. Okay, wow, you guessed my number. Sorry, you did not guess my number. And then we want to tell them what the random number generated was, because otherwise, how would we know whether they guessed it or not? So let's go ahead and run this. Greetings, player 1, generating a random number between 1 and 10. Can you guess my number? Well, let's start in the middle, 5. The random number generated was 1, okay? Well, let's modify that. Let's make a random number between 1 and 3. We'll improve our odds. Now this is a problem because it's hard-coded. So can you guess my number, right? Well, I'm saying generate a number between 1 and 10, but I'm really only generating one between 1 and 3. So let me show you what I'm talking about not hard-coding values. Okay, this is a perfect example. Let's make a variable, and we'll call it max, okay? And we'll assign the value 3 to it. I'm going to take this and I'm going to plug it in. So I'm going to say max here, okay? And I'm going to say max here. Now, if I change this one time, if I change the value of max to 10, well, it changes it 2 places in my code, but I only had to change it 1 place up here. Do you understand what I'm saying? So Now it'll say whatever I type here, 10, 5, 2, 3, 7, whatever. It'll say generating a random number between 1 and whatever I put here. Additionally, as I change this value, not only does it update the value here, it updates the value here too. And imagine if I use this dozens or even hundreds of places in my code, then you can see how programming something this way is more efficient. It's actually much easier to set everything up as a variable that you can easily change and modify. And then when you're coding, use that variable instead of hard coding the value. So I sort of hope that makes the case for that, right? So if we run this, I'll set the value to 3. Oh, let me see, I didn't mean to hit return there. All right, so if we run it, so notice it says enter a random number between 1 and 3. Well, let's start in the middle. We might get lucky, who knows? That's it. Wow, you guessed my number. And the random number generated was 2, okay? And again, we didn't have to parse or typecast this to an integer data type or a double, or because we're really just comparing string values. Read host always takes input as a string. And we're just comparing the string to the string value of the random number. So sort of the ASCII key code value. All right, let's take a look at our next example. So this is a bit more complex. We want to get a little bit more sophisticated, right, with our logic, with our decision making. So now we've got a maximum and a minimum, okay? We still have my number. We have the player's guess. I've initialized my number to be 0, as well as the player's guess. So greetings, player 1, generating a random number between, well, we can change these values. And when we do, because they're not hard-coded, it'll change them all the way through our program. So it makes modifying and maintaining this code easy, right? That's the advantage of not hard-coding a value. Okay, greetings, player 1, generating a random number between minimum and maximum. So in this case, 1 and 10. Then my number, what are we going to do? We're going to get a random number with the get random number function or method. And as arguments, the parameters that we pass in, minimum number, which is 1, and maximum number, which is 10, okay? So we do that, and then read host, we're going to take input as a string and display can you guess my number on the console, store that in the variable over here on the left, player guess. Now we're going to do some basic logic, okay? So we're going to do a comparison. If player guess is less than minimum number, invalid, too low, your guess is below the minimum range. If player guess is greater than the maximum number, invalid, too high. Now notice that there's an else if. So far we've only used if and else. A very simple decision structure, but we're getting just a little bit more sophisticated here with our logic. So there's more than one condition we're testing on. If the first condition is the player's guess less than the minimum number, well, it's outside a valid range. You know, they're never going to get it if they guess something that's less than 1, because we're only generating a random number between 1 and 10. All right, so we test for that condition. And if they didn't add -3 or 0 or something that's totally off the wall, we go to the next condition we test for. Okay, so good. They didn't type in a number that was less than the minimum, which is 1, but did they type in a number that was greater than the maximum? 100 or 5,000 or something? Well, we test for that. Was it greater than the maximum? And if so, we're going to say invalid, too high. If neither this condition nor this condition are true, then we go to the else block of code between these two curly braces here, right? This whole else block. So we've tested and seen that they didn't type in a number too low and they didn't type in a number too high. So now if we get to this part of the code, this block here, we know the number has to be between 1 and 10. but there's still some more decision making we have to do. So we're going to do some nesting. So as feedback to see how this code flows or how it works, we'll say, hey, you entered a valid number between minimum 1 and maximum 10. But we have to do some more testing. So nested inside the else, we have another if-else structure. And now we're going to say, well, okay, so it's valid. They entered a number between 1 and 10, not too low, not too high, but did they actually guess the randomly generated number? And if so, we'll tell them, yes, you guessed my number. If not, we drop to the else, this block here, and we'll say, sorry, you did not guess my number, okay? And then we'll close this outer else block. So this if and else are all part of the code of this outer else block. And this test would never even be performed. If this were true or this were true, that code would be executed and all this code would be skipped. Do you understand? Okay? And finally at the end, we'll tell them what the randomly generated number was. So you're starting to see the beginning of nesting and if and ElseIf and else of a more complex if-else type structure. And you understand that it's very important what goes between the open and closing braces, because that is how your code makes a decision. That's how the logic flows based on the results or the values returned from the test conditions that you pass in. And you don't have to indent, you can be sloppy and type all this on one line. It does take time to indent your code properly and to write neat code. But I can tell you this much. When I first started out, I was a lot sloppier and I would just get in a hurry and code stuff. And then, by the time you get 100 or a couple of hundred or 1,000 lines of code, you go back and it's really hard to debug and track down errors and issues in sloppy code. So, sloppy code works just as well as neat code does. And some people that are total geniuses and really good programmers can just throw up a spaghetti ball of messy code and have it work great. But I'm not one of those. And most people are not necessarily those genius types. So if you are a poor, struggling, average person like myself, you will find it worth your time and worth your effort to write neat code to properly indent things. Because look, at a glance, because I took the time to indent the if and the ElseIf and the else, and I changed the indentation here and I indented all this inside the else block, at a glance from far away, I can see how the logic flows in that code. I can read that code very easily. And that will help me track down errors. That will help me track down bugs and debug it when it doesn't do what I want or when the logic doesn't flow the way that I want it to. Having neat code that's properly indented makes it so much easier to work with that code, debug that code. Or if I was reading someone else's code, it would make it much easier to understand, because I don't know what they were thinking when they wrote that code. Who knows what was going on in their brain. So writing very nice, well-indented, neat code, it's taking the time. Yes, it slows you down a little bit. But I think any time that you waste indenting things properly and writing neat code, you will get that time back and more. You'll get interest on that time you invested. When you go back and you have to fix that code or modify that code or make adaptations or changes to that code. So sort of a plug there. Yes, if you write nasty spaghetti ball code, it works just as well as as neat code. But when you go and try to debug it, or when you give it to someone else and they try to read it and follow it, it's much more difficult. So it pays off. All right, so let's run this code here. We'll throw this into our example. And I'm just going to use the PowerShell method clear. All right. And wait, what have we got here? This is a good point. It looks like I have a error here. It says closing brace. I copied and pasted it. That's from the close of the function. but there's no opening brace. So in order for that to be proper, I'd have to have an opening brace and then function and then some func here, okay? But let me go back. See that red squiggly line? So that shows me I have an issue there. And watch what happens when I run it. Notice the feedback. So this is good to bring this up. It tells me where. This case it's a line number. So 45, right? There's that brace that shouldn't be there, that curly brace. And then character 1. So PowerShell ICE will give you feedback when you have an error. In this case, it's a syntax error in my script. I have a closing brace without a matching opening brace. That's very important. You know, little squiggly braces, you don't always notice them, but they can create issues in your code. So kind of glad I copied that brace by accident because it brought this up. ICE is your friend. ICE is your friend. In this case, it'll give you the line number and the character when you have syntax issues. And that will help you track those problems down and correct them. So let's clear the console and we'll run it again. Generating a random number between 1 and 10. Can you guess my number? I'm going to try 5. In this case, invalid, too high. Your guess is above the maximum range. Well, it's not. And the random number generated was 6. I guessed between 1 and 10. Well, what's going on here? Why is my code not doing what I want? Why doesn't it do what I expect? Well, remember what we said. Read host. It returns a value as a string, not a number, right? So if I'm using equals, that's fine. I can compare one string to another. But if I'm using less than or greater than, and that's what LT and -GT stand for, that requires that they be an integer value, an actual number. I can't tell if one string is greater than another, but I can't tell if one number is greater than another. So we have a problem here. Even though the syntax of our code is good and it runs, it doesn't do what we expect. All right? So that brings us up. If I run this code, if I add a brace, if I run it now, I get what's called a syntax error. Syntax error, line 46, character 10, means that think of it almost like a grammatical error or a grammar error in English. I didn't code something properly. You know, open closing brace or a parenthesis or something, or I misspelled the name of a variable or a function. So that's a syntax error. But there are different types of errors. You don't just have syntax errors, you have logic errors. And a logic error, well, my code works just fine, but it doesn't do what I want it to. I mean, syntactically, it runs. It's, you know, the code can be processed. It's correct from that perspective. But logically, it's wrong. It doesn't do what I want. Something went wrong in the way that I coded this problem and the solution, and it doesn't translate my thinking, into what I want. So in this case, I have to figure out a different way to code it. And the problem is that I can't compare less than or greater than in an if and an else if block if I'm comparing a string to another string. That's for text, all right? And these values came in as text, but what I need is the ability to compare numbers. I need to know, the actual integer value 5 or the integer value 0 or -3 compared to the integer value 500 or 1,000. Okay, so again, invalid, too high. But it's not. I typed in 5. So how can we fix this? Let's take a look at our next example. Guess my random number 3, okay? So in this case, we're doing the same thing, right? We're not going to hard code values. And we're reading hosts, but do you see something different in this line? Exactly. There it is. INT, short for integer. So we are converting or typecasting the result. So the user, the player, they type in their answer. Read host takes their answer, but it always spits out a string. It doesn't know how to spit out an integer. But what we can do is the variable that accepts the result that read host returns from the console, we can convert it from the string data type to the integer data type. And if we do that, then we can actually do some math with it, or we can do some numerical comparisons with it. So that's how this is different. That's just a one way that this version is different. See, notice we didn't do that up here. There's no brackets or braces and integer, but down here we did. Other than that, this is the exact same code and logic. So let's see how that works. And I'm just going to clear the screen again. And I'll tell you what, I'm just going to add a few lines here. So it'll drop down a few lines. And we're going to run it. We can hit F5. I'll click the triangle. Guess my number between 1 and 10. All right, I'm going to try 5. You entered a valid number between 1 and 10. So this time, the logic processed correctly. Why? Because we converted the string data type to the integer data type. And when we do that, then we can actually use the comparison operators less than, -LT, and greater than, -GT. We can actually compare numbers or calculate or do something mathematical with them, because now the data type is the correct data type, the proper data type. So in this case, what happens, I type in a 5, it goes through these tests, and was it less than minimum number? No, 5 is not less than 1, so we're good there. Well, was it greater than the maximum number? No, 5 is not greater than 10. So it passes this test, and it passes the next else if test, right? Both these conditions in parentheses evaluate to be, in this case, false. It's not less than minimum, and it's not greater than maximum. So it actually gets to this block of code here, the ending else block. And then nested inside of that outer else block is another if and else block. So once we get here, we know that they typed in a valid number. It was within the range that it should be. And now we can actually compare it and see if they guessed it. So if it was equal, well, yeah, you guessed my number. And if not, then this inner else clause would be executed within the outer else clause. Sorry, no, you did not guess my number. But again, this entire block, this entire if else is nested within or inside of this outer else block of code. So none of this would even happen if they were to type in a number lower than 1 or greater than 10. Okay? And what happened? The random number generated was 8, and the number that I guessed was 5. So sorry, you did not guess my number. Sorry, you did not guess my number. Okay? Now, what if we wanted to decrease the range? Let's make it between 3 and 1. We'll make this easier. Okay? So I'm going to hit the up arrow, which will repeat clear. I'm going to run it again. So now it says guess a random number between 1 and 3, right? Because it's not a hard-coded value. So I change it here, and it changes it everywhere. It changes it here, and here, and here, and here, and here, and here, and here. I mean, you understand? You see all these lines of code? So that's the advantage of not hard coding a value in your scripts, your programs, your applications. So can you guess my number? Now let's test the logic. I'm going to hit 0, which would be below 1. So what happens? Let's test our logic and see, syntactically, a lot of times your code may work, but that doesn't mean you're home free. Even if you don't have any syntax errors, you have to test it for logic errors. Does it actually do what you want it to do? Is the behavior expected behavior, or the kind of behavior that you expect? So 0. Invalid, too low. Your guess is below the minimum range, which is 1. So good, that's happening like we want, right? Now let's exceed the maximum value and see if it does what we want. All right, so maximum is 3. I'm going to hit 5, which is over. Invalid, too high. Your guess is above the maximum range. So we've tested the logic, and this works as it should. And the else if also works as it should. Now let's test this part of the condition, the else, and the if else nested inside of it. So we'll run it again. I'm hitting F5. I'm going to start in the middle. Might get lucky at a 2. In this case, no, random number was 3. But it did pass this test, right? This was false. It wasn't less than 1. 2 is greater, so it passes the if block. It goes to the else if block. Well, was it greater than max? Is 2 greater than 3? No, it's not. That's false. So it passes this block as well. And that means it finally goes to this block of code. And then it says, hey, well, okay, was it equal to the number? Did you guess the number? And if so, this block of code would be executed here. Yes, you guessed it. Otherwise, no, sorry, you did not guess my number. And that's what happened right here, right? Let's run it again, and I'll try 2 again. I think I'll get lucky eventually. So if I do 2 again, oop, 1. Maybe I'm just really unlucky. F5, run it again. I'll try, boy, really unlucky. Clear, let's try it again. 2. Try it again, F5, run it. I'm gonna keep guessing 2. So, there, okay, I guessed it. This would be a good time to talk about pseudo randomization, but that's a topic for maybe a much later video. The numbers that we get are random numbers, but they're seeded with an algorithm that I guess you could say that it's not totally truly random. It's somewhat predictable. But in this case, logic-wise, it does what we want, right? So I type in a 2. It's not less than the minimum, and it's not greater than the maximum, so it bypasses the if and the else if, these 2 blocks of code, and it goes to the else block. And then it says, did what I type in equal the random number that was generated up here? Yes. Yes, it did. So it says, wow, you guessed my number. And if I compare, here's what I type in to, and here's what the random number was. So hopefully that makes sense. And hopefully that sort of builds on the idea of a basic if-else block and on the idea of nesting decision code inside of other decision code. And also hopefully that sort of hammers home the importance to you of writing neat code and using indentation to your advantage to see how your logic flows in a program. So to review, we've gone over a basic if and else structure, and an if and an else if and an else structure. And we've gone over nesting one if and else structure inside of another, okay? There's another type of decision structure known as a switch, okay? And a switch can make simple decisions, and it's a way to add, it's almost sort of a shorthand method of coding decision logic, okay? So, I mean, I could code this out as if and else and if and else if I wanted to, but it would take up a lot more lines of code, you understand? So sometimes when I want to make a very simple decision on a bunch of different values, a switch statement is more efficient than an if and else statement. But it's essentially doing the same thing logic-wise. It's making a decision based on a value, or the return result of a function. So a switch statement would always have the keyword switch. It would have open and closing braces, just like an if and an else block would. And then within that switch statement, there would be cases. And each case would have a value. Could be a string value, a number value, a single character. And then they would be inside of open and closing braces themselves. And that's the code you want to execute based on if that value was detected or if that was the result of what was in the parentheses of the switch statement. And every switch statement can have also what's called a default. And so the default is sort of like the ultimate else. Like we have this else here. So if this was not true, and if this was not true, then this else is sort of the catch block. It catches everything that did not happen in the if or the else if. So you can think of a default in a switch statement like that. All right, it's like that catching else block that we had up above. And so you don't have to have a default, but most switches do and should have a default to deal with values or contingencies that you hadn't planned for in your code in that switch statement. But it's a bit more efficient. It's almost like a shorthand method of coding decision logic. So let's see what happens. Read host, how do you feel today? Feelings, and then these are potential answers that I could type in. So we're just going to run this, and in our first example, let's get rid of all that code. We'll test it on a string value. So emotions I understand, happy, sad, angry. How are you feeling? We use read host. We take input from the user. We store it in the variable on the left in feelings. And we're going to switch or make that logic decision based on feelings, okay? So hit the up arrow to clear, hit F5 to run. Emotions, I understand, happy, sad, angry. How do you feel today? Gonna say sad. I type in sad. I'm sorry, need a hug. Well, why did that happen? Because I typed in sad. The string value was stored in the variable feelings. I switched on the variable feelings. And the value matched this case right here, the second case. Sad. And so it said, I'm sorry, wrote to the console, I'm sorry, need a hug. Let's run it again. I hit F5. I'm happy. Yay, I will rejoice with you. Why? Because I stored happy here. I tested the condition here and it matched the value here. So it runs the code. Yay, I will rejoice with you. F5, run it again. What if I'm angry? Close your eyes, breathe deep, count to 10. Some anger management. Why? Because I stored the value angry here. I tested the condition, the value here, and it matched this condition, this case. So this block of code was what got executed. And what if I hit F5, run it again? What if I type in a value banana? A Gwen Stefani answer. In this case, sorry, I do not understand that emotion. Why? Because that was none of these conditions. It didn't match happy, sad, or angry. I typed in banana. Now that might mean something to Gwen Stefani, but that does not mean anything to our code. We didn't tell our code how to deal with banana. So the default would then be executed. That's why it's good to have a default in any switch statement, just to deal with things that you're not expecting or that the user might do or contingencies or values that might show up that you didn't plan for. Okay, so basic switch statement. So what if we try that with guess my number, right? Let's look at this code. We'll throw it over here. My number is 3. We ask the player, guess my number. We input it. And then, in this case, we're going to switch on it. So, hit the up arrow, clear. I'm going to hit F5 and run this. Guess my number. What happens if I input 2? My number's higher. F5, run it again. What happens if I put 3? Yes, you guessed my number. Why? Well, the first time when I input 2, we switched on it. Last time we were switching on string values. This time we're switching on number values. Either way, it's the same. It still looks at the string character content, but okay, so I typed in 2 up here. What does it say? Hey, my number's higher. Next time I ran it, I typed in 3. What does it say? It matches this case. Hey, you guessed my number. Now, if I type in anything between 1 and 5, let me hit F5, run it again. What if I type in 0? Invalid guess. Guess a number between 1 and 5. Let me hit F5, run it again. What if I type in 7? Invalid guess. Guess between 1 and 5. So because those were outside the case values of 1, 2, 3, 4, 5, it ran the default case condition instead inside the switch. So is that beginning to clarify and to gel? Do you see how switches work? And you can pack a lot of decision logic into a small amount of space using switch statements. They can't do everything that if and else and if and else if and else and nested if and else can do. So sometimes, actually a lot of times, for more complex logic, you need to use if and else if. But for very simple logic, or for testing for a large number of conditions in a small amount of space in your code, a switch can be a very useful tool. So you have to kind of, when you're coding, go back and forth, but knowing the limitations and capabilities of switches versus if and else if and nested if else structures. And that will determine what kind of structure you choose to represent the logic you're trying to code. Okay? So we're going to make a simple DOS menu in this example. And how would we do that? Well, we're going to use a switch statement. We're going to display some things. Main menu, create a Pokemon, display a Pokemon, save, load, build, exit. By the way, this is an actual project we'll do later. Once we've learned some more things and gone over other things in subsequent videos, one of our projects will be we'll build a Pokemon game. And we can actually use this menu in our Pokemon game. But all a menu at the console is basically we're displaying options for the user to give them choices. In this case, we want them to select a character to choose an option here. We're going to switch on it. And in this case, notice that I don't have to pass in just a variable, right? Or a predetermined value. In this case, I can actually grab input from the user, read host choose, and I can feed that into the switch. And based on that, I can do different things. So in this case, I'm switching, my test condition is the string value that gets returned from read host. So I'll switch on it. And if they choose C, well, we'll create a Pokemon. If they choose D, we'll display a Pokemon. S, L, B, X, I'll save a Pokemon, load a Pokemon, build a Pokemon, or exit. And if they type in something weird like Z or something I didn't ask for, I have a default to deal with that. Hey, invalid entry. That's not a menu choice. It's not a menu option. So here's a pragmatic example of using a switch, in this case, to construct a menu. And you can have dozens of these types of menus in a console-driven program in PowerShell. It's kind of a quick and easy way to do menus. You can also create GUI menus for your PowerShell scripts, and we're going to go over that later. But a lot of times it's quicker and more efficient to build your menus in the console right there in your code. So if we were to run this, let's just see what happens. I'm going to type in clear and clear the console over here, and we're going to run it. So it's waiting for my input. What do I want to do? What if I type in C? Create Pokemon method. So what happened? This displayed create Pokemon. I take that input, create Pokemon method. All right, so here's where I'd write a function, and that function might have hundreds of lines of code or dozens of lines or however much code it took to create a Pokemon. And I would invoke or call that function from these curly braces, this case inside the switch. By the way, we haven't used this yet, but it doesn't work with write, but when you use write host, you can change the text color. So I pass in the foreground color parameter, and I can do red, cyan, blue, all kinds of things if I wanted to. Okay? And then based on these cases, so if I run it again, hit F5. Let's say I want to save a Pokemon. I hit S. What happens? Okay, I display S. I input S. It goes into the switch statement. It matches this value here. So it executes this block of code here. What does that do? It displays to the console save Pokemon method, and it makes my text color red, right? So I'm changing the color of my text. And I can do, just to show you, cyan. So if I wanted to, and that was save. So let me save a Pokemon. See? Now it's cyan. So I can make it different colors. How about yellow? And I'll scroll up here and now it's yellow. See? So another basic switch statement, example of using a switch to construct a menu and being able to change your text color with the right host at the command prompt. Now let's take a look at our number guessing game. But what if we were to code our number guessing game with a switch statement and if and else? Remember we had an if and else statement nested inside of another if and else statement before? Well, this time, what if we combine our different decision structures? What if we combine a switch with if and else logic? Could do the same thing. Get the same logic. It's just syntactically a different way of coding the same solution to the same problem. So here we have it. What are we going to do? We have the same values here, the minimum and maximum value of 1 and 5. And we'll display that generated a random number between 1 and 5 to the player. We generate the random number here. We store it in this variable. Remember that whatever the player types in, read host takes it as a string. So we have to take that and we have to store it in this variable and then cast it to an integer. And then, and only then, can we do some math with it or some numerical comparisons, such as -lt-gt less than or greater than. Then, if they didn't type in anything too low below 1 or anything too high above 5, then and only then will we execute this outer else block, which executes the code in this inner portion here, this inner block, the switch statement, the player's guess. And here we're doing, well, was it less than the number? You guessed less. Was it greater than the number? You guessed more. And then did they actually guess it? Did they guess the number? So notice that, we did a simple string in our switch. We used a number in our switch. We used a single character in our switch. Now, some programming languages won't let you do this with a switch statement. Switch statements are more simplistic, such as C++ and Java. But in PowerShell, you can actually do this. And we can make another comparison. So we're making a test or a comparison here, but we're making another test or comparison here. And in this case, this is a shorthand method. If we were going to code, we could do all this with if and else, and then another if else inside that, and another nested if else inside that. But this might be a more efficient way to do it. Okay, this is consuming less space, but giving us the same kind of logic. So let me clear the screen here, and I'm just gonna add a couple of lines to drop it down some from the top. I'm gonna hit F5, or I could click the arrow, whichever one. So guess a random number between 1 and 5. Well, again, let's test the logic. What if I say 0, below the minimum? So if it's less than minimum, it tells me invalid, too low. That does what we want. The logic works as we expect because we cast it to an integer. Let's try it again. I hit F5, and what if I go too high? What if I put 7 in? Invalid, too high. So it told me too low here, It told me too high here. And that's this ElseIf block that's being executed because yes, my value exceeded the maximum value of 5. Let's run it again. I'll hit F5. And now I'll type something within that range. So 3 in the middle. It's greater. It's not less than 1, and it's not greater than 5, so it's valid. And then in this case, we make it into this last block of code here, right? The catch-all else. And in this block of code, we switch based on that. And what happened? I guessed 3. The random number generated was 4. So what happens? My number was less than the number. So it told me you guessed less than my number. See? Let's try it again. I'm going to clear the screen. I'll hit F5. Guess my number. I'll try 3 again. This time it was also 4. And so it tells me guess less than my number because my guess was less than the number. So this entire block, this case, what we call a case inside the switch, is what gets executed. Let's try again, F5 to run it. And this time I'll enter 3 again. And now it tells me guessed more than my number. So this is what happened. Because what I guessed was greater. You know, the random number generated was 2. The number I guessed was 3. It was greater. So this is the case that gets executed, right? Okay. And honestly, if I get here, I've already tested to make sure it wasn't outside the range. It wasn't less than 1 and it wasn't greater than 5 here and here. So I don't have to worry about that. But what if I were to type in some crazy nonsense? Never underestimate the user's ability to break your code or do something unexpected that you didn't plan on. For instance, it asks for, can you guess my number? Well, what if I type in the character Z? See what I'm saying? Never know. So I wasn't expecting that. And in this case, we'll go over try catch later. And we'll go over different means of handling input. But notice line 18, character 10. I'm trying to convert this to a number. But how the heck can I convert, in this case, a character Z to a number? I can't do that. So, the problem is not with my code, and the problem is not with my logic. The problem is the user. The user's acting like an idiot and typing in values that they shouldn't type in, that my code's not expecting. Never underestimate the temporary insanity of an end user. So we'll go over bulletproofing. We'll look at try and catch and if and else and ways that you can bulletproof, what they call bulletproof your code. And so you try to think of all the crazy, unpredictable, random things the user's going to do to mess up your code and mess up your logic. And you try to code your program so that it can fail gracefully, or so that it can handle that user's temporary insanity or madness and not completely crash. But that's a more advanced topic for later videos at a later time. That's the point I'm making. But I said all that because that's another reason to always have a default inside of your switch statements. In this case, this would never normally get called, never normally get executed, because I tested it's not too low and it's not too high. But then again, is there the possibility that even if I'm in a valid range of 1 through 5, would they type in some craziness? Okay. Now let's look at this. In this case, we are going to do, oops, almost grabbed that brace there. That would have been a brace issue. Let's look at this last example here. I have a number, it's 3, guess my number, and again, it's just a simple switch, right? And in this case, I'm using the break keyword. Break is a keyword that would cause my script, my function, my application to fall out of a loop. We're going to talk about looping and repetition structures And I guess the video after the next video, or very soon, we will hit that topic. And this keyword will become more important. But just recognizing a switch, a break statement, or within a function, or other type of logic structure, a break statement would cause it to leave or exit that loop condition. In this case, it's not in a loop. Doesn't really do anything. I just threw it in as an example, but F5 to run it. Guess my number. What's my number? 3. I put the number 3 in. Yes, you guessed my number. F5 again. I'll try 1. My number is higher. So you get it. And if I went higher, it would tell me my number is lower. If I hit F5 again, I hit 4. It tells me my number is lower because it matches this case, a condition. So hopefully that clarifies and illustrates how a switch statement works, how if and ElseIf and else work. And as you begin to work on some of the projects and code these things for yourself, I'm personally a tactile learner. I'm very kinesthetic in how I learn and acquire something. So you can tell me something 10 times and I won't remember it and I don't get it. You can even show me. Now, if you model it for me and show me, that's a lot better than just telling me. I'm going to pick up a lot more of it. But if you really want me to learn something, you have to make me do it a few times. And then once I do it, it sticks and it drives it home. And I think a lot of people are that way. So don't worry if we're going over this and this is new to you, don't worry about it. As you begin to code solutions to problems, as you begin to write your code and write your scripts and write your apps and things, you'll start to remember it and you'll start to understand it. And it'll become very much second nature to you. But only when you actually begin to use it and code it. So I'm going to put this code up and you can copy and paste this code in ICE or in whatever IDE you're using. And you can run it and test it, but it's not really going to help you unless you actually type the code out and create things from scratch and then edit the code and modify the code and do different things with it and break it and fix it and break it and fix it. And as you manipulate it and as you actually begin to code for yourself, then kinesthetically in a tactile way, it'll really start to stick. So that's my recommendation to you. I'm going to try to always include the source for these projects, either on GitHub or somewhere. I'll put it on YouTube or somehow, or a website. But it's not going to help you to just copy and paste it. You're not going to really learn anything. You're only going to learn something when you take the time, hours and hours and hours of your time to type out code yourself and break it and fix it and break it and fix it and have syntax errors and fix them and have logic errors and debug it and go through the code and fix it. And in that process, that's the process where you actually, begin to understand and begin to learn. Think of it like bodybuilding, Wouldn't do you any good to sit there and watch somebody else lift weights for you all day. I mean, you might learn something about their technique or how to lift weights, but that's not going to put any muscles on your body if you're not actually working and exerting effort and sweating and burning calories yourself. It won't profit you at all. And I think, coding's kind of that way. Doesn't do you much good to watch somebody else do it. I mean, they can present a topic to you. They can show you a technique. They can present a structure. But until you grab that and you begin to create things with code and write things with code and break things with code and fix things with code, I don't think you necessarily get it. You know what I'm saying? I don't think it necessarily does you a whole lot of good. So yes, I will make the source code available, but if you really want to get anything out of these videos, I recommend that you actually, pause the video when you need to. Type the code out in ICE or in a compiler in your IDE. See what it does. See how it works in a very kinesthetic way, from a pragmatic perspective. How does the code work? What does it do? What is it good for? What can I accomplish with this new programming structure? Okay.